Alright. Guess that is what it is. It's fine. Hello, hello. So let's get back into it. What is it I'm going to do? So I have the okay. So I have so to play really yaw with a pitch. I could set the player position to be also not a vector, but I think having the X and Y is super important. Okay. I mean, sure, I could do the whole, 1-1 and 1-2 thing for like X and Y and all that stuff. But I don't really like that idea, right? So I'm going to do things a little bit differently, right? So we have the map mole. We can do a function match add a comma b, right? Local c is equal to 0, 0. Oh, actually, I can return. I mean, right. So this is for two-dimensional vectors. Oh, hello. Hello. So let's see. This isn't very good. Next one would be for okay. I mean, days off are days off, but they're good. They're important too. So one of the things I could do is a local C is equal to a table. I don't know if this is actually going to work, because I feel like do ci equals for I, yeah, c is equal to a table, right? So we initialize the outer table, we initialize the inner table, and then we set it to 0, and then we plus that, yeah. I'm gonna do another thing. Hang out all your vacation hours. Yeah. I mean, I would. Yeah. So, why do I keep doing that? Of course it's not gonna work. So local C is equal to a table, and then for well, I mean it's column major, right? So for call in A, do C call is equal to a table. For row in hash A1 do, right? C call row. Oh shit. That worked. Is equal to A column row plus B column row. And return C. Gonna do that. Oh yeah, I touched up my face, touched up my VTuber, my PNG a little bit. Looks a lot better. The mouth is a lot more natural. So there is that, and a few other touch-ups that I made, like the transparency, the transparent background, and all that stuff. I haven't really been listening to a lot of different music. It's mostly just been, you know, what this playlist is and stuff like that. I want to listen to more music, but, you know, Radiohead. Been listening to a lot of Radiohead. Well, I mean, it's mostly just a lot of the same Radiohead. Everything in Its Rightful Place is a really good song that's been kind of helping me keep going. So, that's been nice. But, let's see. We have... Okay, yeah, so we have the mouse moved, which we will be using to... I don't think I actually want the deltas there, right? I don't know if I want all those to be there, or if I want to... Because, like, it would make a lot of sense if I just didn't deal with the mouse, and I only just straight up built these guys up, because like because when mat add, I could change that to be something more conducive. Alright, function mat norm a local, what is it? Local B. Shit, I need to do the determinant. How do I find the determinant of an arbitrary matrix? Because for a 2x2, well, I mean, there's a way to take a matrix of any arbitrary number of rows and columns, and then you like break them down into other components. So like you how do I put it? You so what you do is you basically recursively split it into smaller and smaller parts. And so you have a 2x2 set, right? But I don't remember exactly how to do that, right? So off to Google, because there is because if I could do the determinant, matrix det A, and algorithm. Fucking example. Yeah, because there's like okay, there's a whole example. Oh, hey, work. I'm trying to look up the determinant of a matrix. So of an arbitrary matrix algorithm. So like I want to be able to do an arbitrary. There's like a really good way of doing it. So why is one? So 1 2 4 1 1 1 3 2. Yeah. So yeah, cofactor expansion method. because I like forget how to do. Because there's like I'll have to do some research into it, I guess. There's like a way that you like split up the matrix in a way that makes it so that you don't have to worry about adding, like, toggling the signs and all that stuff. And I think the way that you do it is you go into draw E. But I think the way that you do it is you come on, draw. You basically let's see here. Alright, so if you have some arbitrary system, right? A, B, C, D, E, G, H, I, right? Or something like that. Then the determinant of this is equal to A, E, F, A times the determinant of E, F, H, I, plus E times the determinant of A, C, G, I, plus, what is that, A, B, D, E, I times the determinant of A, B, D, E. Right. Because basically what you're doing is you're saying this times this. This times this, right? And then you have this times this, right? Basically the matrix not including that row or column. Right, and then you just add those all up. Right, and just add those all up. So like for, and I think you can only find the determinant of a square matrix. Otherwise you end up throwing errors and a bunch of bad shit happens if you don't, right? So yeah, so you need full determinant calculator cofactor expansion or LU composition. Hello, Zumi. I do have 3 loops. I have 4, right, on line 32, right? I have 4i, 4j, 4k. Right, like if I split these up a little bit more, it's a lot easier to see the 3 loops, right? And also this is column major. Yes, I am streaming late. I'm also too loud. I need to check my volume. Oops, getting a little bit too excited. Yeah. So or upper triangular determinant times. For general management, you need full determinant calculations. Yes. Product of diagonal only. Yeah, no. So yeah, I have the 3 loops, but what I'm saying is that it's not really. I'm not doing a full diagonal. It's more of what do you call it? It's just you. It's because like you have a plus minus plus minus plus minus plus minus plus, right? Because every time you change to a different row or column, you end up toggling the sign, right? So if you have the cofactor be along the major diagonal, the major diagonal, then you don't have to worry about toggling the then you don't have to worry about toggling the you don't have to worry about toggling the sign. Correct. Yeah, I'm implementing the cofactor expansion. Yeah, so because of that, I can just switch things around super easily, right? Because if I go along the main diagonal, right? Because if I make the cofactor along the main diagonal, then I can just kind of plug it in for anything, and it'll just recursively boil down, right? Because it could be any size, you know. It could be, you know, like 1, 2, 3, you know, all the way up to like 27, right? And then it'll just kind of recursively boil down. That's just something that you can do. So what I need to do is I need to have the full, right? It's just like, is the cofactor expansion, the determinant, efficient? Probably not. But it's easy to implement, right? And I'm not doing hundreds of thousands or millions of matrix operations in a single second, right? I'm doing a handful, so it doesn't matter, right? I don't care about the end all be all highest height of, you know, right. I am going to separate this though, just to make these a little bit more clear. All right. Yeah. So the matrix add is really easy. That's super awesome. But the determinant is going to be, so yeah. Yeah, I mean, you can. Or you can go along the main diagonal, right? Because what you could do is you could just have, you know, local s is equal to 1, right? And then, you know, for I in, you know, a u. Yeah, you could like build the thing and then you just do like an s equals s times -1, right? You can't just do that. That would work. But it's also easier to construct. Also, the cofactor matrices are easier to construct if you go along the main diagonal, right? Because what you're doing is that you say, you're creating. So as you go along the main diagonal, well, I also need to figure out if the input is I also need to find out is if a is equal to 2, then return a 1, 1 times a 2, 2 minus a 1, 2 times a 2, 1. Right. This is the that is the base case. Okay. This is the base case, and then for in here, we want to say a local but yes, the -1 to the power of 1 plus j is also fine, right? That also works. But so local debts is equal to sounds like fighting game combos. Yeah, a little bit. Welcome to linear algebra. I hope you enjoy your stay, Zumi. Matrices and shit. Right. Right. So local debts. So so let's think about how one plus 2i, 3 minus I, 4, 5, 4, 5i. Numbers of the form a plus bi, where I is equal, yeah. I mean, I am going to be doing imaginary numbers. I'm not going to be doing spinners, but I am going to be doing imaginary numbers. Yeah, I am going to be doing imaginary numbers, but I'm not going to be doing spinners, though. Because I don't have, and I would actually prefer to be going into geometric algebra rather than linear algebra. I mean, I just prefer geometric algebra over linear algebra. But, like, it's fine. Right? I mean, these are, like, these matrices are my imaginary numbers, right? Or I should say complex numbers, right? So, my complex numbers, namely, that, namely, what I'm going to be doing is, like, this, right? This is 1 plus I in matrix notation, right? So that's why I'm doing all the matrix stuff, because it's a lot easier to manage these if I do that. And also I have matrix just on standby. I do believe that computationally this is way less efficient than just screwing up complex numbers. Passing complex numbers through matrix operations is like really bad. But I also want to get into the habit of like coming up with algorithms and stuff, right? That's part of the reason why I'm doing this, why I'm deriving a lot of this stuff, right? So the way this is that this is a times, yeah, it's a 4I in a do a I times the debts, the debt of you know not a I. So what I need to do is that up here, you know, like that, right? So I need to have a determinant is equal to 0, right? And then determinant equals plus that, and then in here I need to create the need to build this determinant, right? I need to build this matrix. Oh, I need to build this matrix and then get the determinant of it, right? Well, this matrix, right? So yeah. I'm sure there's nice, pleasant, efficient ways of doing that. I'm not so sure if I'm gonna be the one to do that. I'm gonna be doing those nice and so yeah. So local that equals 0. So within here, first local that is equal to thing, and then for what is it? For C hash pay -1 -1 do that C with that for R and hash a -1 do that C R column row is equal to. See, this is kind of a problem. So Yeah. It's just that I really don't like using like I really don't like doing if statements, because like in GLSL this is literally just what a the what is it, ints of C what is it, C plus ints C greater than or equal to I, right? I can just do this, right? But I don't know. I'm just gonna try adding a boolean. Alright. I'm gonna try and add a true. See if that is a thing. Let's just try it. Oh. I didn't throw an error here. Oh, I know what I can do. Legit. So return 3 plus 3 greater than or equal to 1. Attempt to perform arithmetic on a boolean stack trace. Shit! Can't do it. Is there like trinaries? I don't want to do if statements. This would be so easy to do. I want to do it like this, but I can't. Alright, fine. But there trinaries in there? Can you do trinaries in Lua? Cause I just want to cast the boolean to an integer. Like, come on. How hard is that? Like, come on. Dual to a number in Lua. There are trinaries in like C or Python. True is not evaluated. Huh. Oh. Oh. Okay, so I can do oh, hold on. There we go. I want that. I want that. Here. And 1, 4, 0. Right. I think Right? Yeah, unfortunately Lua doesn't have casting. Which is, you know, kind of a problem. I don't like that. So return 3. 3. Okay, then we have to 2. Yes! Okay, so that does work. I don't really like that, but I don't like how messy that is. But it does work. So that will work. And then after the mat is constructed, do det equals det plus. I also don't like that it doesn't have a plus equals. So not boom factorial. I think that'll always evaluate to 1. Plus a at I at I at II times mat debts of mat. And then debt. I think this is the proper thing, right? I can clean that up just for shits and giggles. I can also just clean this up, right? It is a little bit harder to read, but I mean, it is what it is, right? So the matrix determinant. And then here it is equal to and then for C in A do for in So here we do B at C. Look at that. so here, what do we have? We have so we got B, yeah, B, C, R is equal to A, C, R. I mean, I'm sure there's some way of doing something. I don't fucking. Oh, actually no, because you have to sweep through the entire. Because in order to do a determinant properly, you have to sweep through the entire thing. Alright. Okay. So I think that's it. And then I can just return B. Right? I do believe that's. Yeah, because it creates a whole new one and then does a thing, right? Yeah, and then you just do what you do. And I'm just assuming that it's not turbo dumb about memory management. Yeah, I need to do. Oh. Yeah. Okay. So I'm locking this to scope so that gets destroyed at the end of it, and then if I return B, it returns it by value. I think technically it returns it by reference. I don't know how Lua works. I am unbothered by the full memory management patterns of Lua. I just use it to do, to make shit happen on screen. So what is going on here? Let's get rid of all that garbage, and what we can say is we can say that, player dot yeah. Do I want to? I don't want to add. I think I want to multiply. Right? Because I want to multiply. So I do like a map mul between player yacht and a constructed matrix. of some shit. Right. I think purely in the imaginary. Well, I mean, I could just do local MDY is equal to a thing of, I think, yeah, Zumi, you're behind me. Oh, I know, I don't want MDY, I want MDX. So the MDX is going to be that norm of a matrix that is going to be 0 dx minus dx0. Is this a good way of doing things? Not really. Right. But it is a way of doing it. Largely because stuff and things. So yeah, so we have the dx, and then how do we use this? So player dot yaw is equal to mat mod. Specifically player dot yaw, and then dx, and then screen send, and then I do believe screen GLSL. There we go. Okay. And then I'm hoping that I can just send in the player dot yaw. Right. I'm hoping that that's all I needed. I'm also hoping that it's actually a thing. So I'm gonna test this. Fuck a blue ball. See if it does anything bad. No. Fine. 75. Under. Under. There's no. Under. I don't understand what's going on here. So why is it... Why... Okay. So it is in 75. No. Okay. Attempted to. No. Function. No. So the issue that we have is it's not. Why? Monday. Am I doing it wrong? What do I do? C, C++, yeah. Oh. 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 Okay, which also means I need to do. Okay. And that should be good. Not quite. That add is also incorrect. And all these are incorrect. Okay. So this should actually be good to go. Number expected got no. None there. So okay. I mean, what I can do is I can say. What I can do is I can say function. Local function local r local maths is equal for C, call in I pairs of player dot do for our net. R actually value. So 444 and return that. I think that's good. There we go. Okay. Okay. Nope. Expected number dot now. So as soon as I move, send. So it is being add argument 4 and send expected dot. Fine. Okay. see if this works. Did the index in there? Out. Did the index in there? 5. No. What's going on here? Oh. What am I gonna do? Okay. Why is it not working? Okay. We'll do it this way. Nanda. That's a no value. Why is it no? That is player.pause, player.yaw, player.yaw, no. 'Oops, if I do do. Okay. I guess I just do that. 0. Okay, that looks good. Oh, but the delta is also... I don't know if the delta is actually like accurate or anything. I don't know why it's so small. What is the delta? I wouldn't expect the delta to be that... I expect the delta to be very big. I feel like I'm burning too many brain cells. I'll just have to... That's not normalized. That's not normalized. Okay. I am too smooth brained currently to do this, so I'm gonna end the stream here.